Bright Tuty. Every student matters.
thorough with. Okay, so let's move to some of the examples here. Find the area of a sector of a circle with radius 4 centimeter and an angle of 30 degrees. So what is this angle? Angle of this sector is the angle subtended at the center. This is the angle the question is talking about, and this is my radius, which is 4 centimeter. So this is also 4 centimeter. Okay, this is the center. Okay, I need to find area of the sector. So I need to find area. Let us name this point P. I need to find area of the sector. So that is minor sector. Okay, it is not mentioned which sector, so we will take it as minor sector. So area of sector OAPB is equal to how much? Theta by 360 pi r square. So what is theta? 30 by 360 pi r square. So r is 4 squared, right? Now if you cancel it, so it is equal to pi into 16 by 12. So it is equal to 4 pi by 3, and the area, unit of area will be centimeter square. Okay, if you want to calculate the exact value, so you should take pi as 22 by 7 or 3.14. If it is not mentioned in the question, you can take anything. So you take 22 by 7. So what we can do is replace pi by 22 by 7 and 3, right? So now you can calculate 88 by 21. Okay, so it is approximately equal to 4 point something, right? So I leave this calculation part to you. Okay, so you calculate this and write the answer up to 2 decimal places. So this is the area of minor sector. Now if I want to calculate area of corresponding major sector, what will I do? I need to calculate this area now. So what I am going to do is I will subtract the area of this sector, which we have already calculated, from the area of this circle, right? So area of the major sector will be equal to pi r square minus theta by 360 pi r square, right? By theta I mean 30 degrees, because in this question theta is 30 degrees and radius r is 4 centimeters. So I can replace r by 4 and theta by 30 degrees. Okay, so this is 12, right? So this is equal to pi into 16 common 1 minus 1 by 12. So it can be written as 11 by 12 into pi into 16. So if you further simplify it, you can write it as 44 by 3 pi, and the unit will be centimeter square. So this is the area of major sector, right? I am not calculating it in decimal form. What you can do is you can replace pi by 22 by 7 or 3.14 as per the instructions given in the question. If the instructions are not given, you are anyway calculating the approximate value. You can take anything 22 by 7 or 3.14 as per your comfort, right? Okay, find the area of segment Ayb. Here this is, let us say, center O. If this point is A, this is B, then we are talking about this segment here. If I name it as Y, I need to calculate the area of this segment Ayb. Okay, now radius of this circle is 21 centimeter and this angle AOB is 120 degrees, right? So to calculate the area of this segment, what I need is area of sector OAYB, right? If I get the area of sector OAYB, I can subtract the area of triangle OAB from it. Now this will be the area of segment AYB, right? So area of sector OAYB is equal to theta by 360, that is 120 by 360 pi r square, which is 21 squared, right? So this is 3, so this is 21 into 21 by 3 into pi, right? So this can be written as 147 pi, and the unit will be centimeter square. So this is the area of sector OAYB. Now I need the area of this triangle OAB. Now as discussed in the introduction part, this angle is 120 degrees and this triangle is an isosceles triangle, right? So let me recreate this triangle here. If this angle is 120, let us say this is OAB, right? This length we know is 21 in centimeters. This is also 21. Okay. Now to calculate the area of this isosceles triangle, what I am going to do is I will drop a perpendicular, right? And we know that in an isosceles triangle, the median, let us say these two sides are equal. If I drop a perpendicular here, this perpendicular acts as angular bisector, median and altitude, right? This is in case of an isosceles triangle. And we know that these two triangles are congruent triangles, okay? We can prove them to be congruent by SAS, or we can prove them to be congruent by using right angle, hypotenuse and side, right? So let us say this angle is 90 degrees, this is also 90 degrees. If this is 120 and this is an isosceles triangle, so rest of the angle is 60 degrees, it will be divided equally here and here, right? So this is a right angle triangle, this is a right angle triangle. This side is common to both the triangles, okay? So side OA is equal to side OB, side OM is equal to OM, okay? Now we know by RHS congruency criteria, triangle OAM is congruent to triangle OBM. Okay, there is a right angle in both the triangles, hypotenuse are equal and one side is equal. So these two triangles are congruent. Okay. Otherwise, if you know that this is also an angle bisector, you could have said that these two angles are 60-60 each, right? And then all these angles are equal and one side is equal. So by angle side angle you can prove. Otherwise, side angle side you can prove. So anyway, you can prove these two triangles to be congruent. So now we know that this triangle OAM is a 30-60-90 triangle, right? So these three angles are 30, 60 and 90 degrees. So I'll apply some simple trigonometric ratios to get the side AM and side OM. Okay, and these two triangles are congruent. So if I calculate area of OAM, then I'll double it to calculate the area OAB. Okay, so if I apply sine 30, it is equal to opposite OM by hypotenuse 21. Sine 30 is 1 by 2, so OM is equal to 21 by 2, right? To calculate AM, I will apply sine 60 in this triangle, so it is equal to AM upon hypotenuse, which is 21. So sine 60 is root 3 by 2 equals AM by 21. So AM is equal to 21 root 3 by 2. So area of triangle OAM is equal to half into base AM, which is 21 root 3 by 2, into height OM, which is 21 by 2, So it is equal to half root 3 by 4 21 squared. I have kept this half aside because I need to multiply it by 2 to calculate area OAB. So area of triangle OAB is equal to double of it, right? Half into root 3 by 4 21 squared. So it gets cancelled. So it is equal to root 3 by 4 21 square is 441, right? Now I have got the area of this triangle, I have got area of this sector. So area of segment AYB is equal to this 147 pi minus area of this triangle, which is root 3 by 4 into 441. The unit will be in centimeter square, right? This calculation part I am leaving it for you, right? You can take this pi as 22 by 7, 147 into 22 by 7 minus root 3 by 4, 441. You can cancel this. This is 21 into 22, right? So you can keep on simplifying it like this, 42, 42, this is 462 minus 441 by 4 root 3. Now root 3 can be taken as approximately equal to 1.732. So you take it as 1.73 and then do this calculation yourself, and don't forget to write the unit of this area, which is centimeter square, right? So this is how we will calculate area of segment AYB. Okay, I hope this concept is clear to you by now.